Okay, welcome to the walkthrough of my hell code, my custom hell code, which will hopefully help some guys out who are battling with their hell code and understanding what's going on. I don't quite understand what's going on some of these things, but I do have a basic understanding, and I figured, let me see if maybe I can help some people with it. Okay, so my machine has got a start and pause button. So this is code that I copied off of the LinuxCnc for one of the forums. I found this and literally just extracted this part. Basically, it gives me a button that will pause the code and resume the code, or the running of the machine. If you pause and then you hit the start button, it single blocks. And if you're in auto mode and you hit the start button, it starts running the code that is loaded. This stuff in the top here, I don't really understand that much what's going on. From what I understand, we are loading variables and setting their default values, and here we're sticking them into the servo thread. The stuff that you'll need to edit, so that kind of stuff will get dragged, you'll pull in if you're copying code from somewhere. This is where you would be editing. So here we basically are assigning the button, so that would be this, and then there's some AND logic. Again, don't really understand, copied this code, and we're attaching it to a parallel port pin on parallel port 1, which is my second port, to pin 12 as an input. Quite important, this piece here, that it is set up as is. Obviously the pin number and port number will vary. It then goes through all parallel logic to, it looks at the hell UI interface and checks if the program is paused. So where you see hell UI.program is paused, that will be a hell UI variable that is set from the software side. Then same thing down here, where we have got the run step button. Again, just looking if the parallel port is high or not. That's basically it. It's not my code, so it does its thing. What I did then was I've got lights on mine. I've got an RGB LED on the top. The green light is saying that the machine is running G code. Red light is that the machine is paused. So if I put an MOO in my code, or an MO1 and have optional stop enabled, the light will go red while it's paused. I then have a blue light that says tool change is waiting, but we'll get to that now. So what I did was I linked run on, which is a variable that I found in the start pause code. It's over here where they've linked it to is the program running in hell UI. So I started by doing that, and then I actually just took their variable, because by going net you set your variable name, another variable, and then the input that feeds your first one. That I got from the hell UI basics. So basically all I did was I linked run on to parallel port pin 16 as an output. Same thing for pause. I picked up pause on from above, writes it out to a parallel port pin. The tool change, I basically created tool wait, and I linked it to the hell UI manual, or the hell manual tool change dot change. So this is saying that there's a tool change that's waiting for, this pin goes high when it's waiting for you to change tools, and it's got the little pop-up windows asking you to continue. The tool wait is my own variable, and then I wrote tool change to pin 14, and that turns the light on to blue when I need a tool change. That is all done via relay, so when the blue light goes on, it turns off any other lights. I've got it normally open and closed wide that way, but you can figure out how you're going to do that. We now get on to the jog pendant part. This is where a lot of guys are actually interested in. Basically what we're doing is we are loading in the encoder we're loading the variable. The mux for, I don't really understand what's going on there. I couldn't find any documentation, but it works. We then load it into server thread, base thread, and server thread again. Okay, here is absolute mode, where for every click you move, the motor will move that, or the axis will move that amount. So if you spin the thing and it spins 300, your motor is moving 300 increments. Whereas velocity mode, you spin it, as soon as you stop it, the axis stops where you stop. It doesn't necessarily count the number of steps. When you stop moving it, it stops there. So I've basically set up, I put each axis into mode 1, which into velocity mode 1. So basically turns velocity mode. I did that for all 4 axes, so 0 through 3. 4 times mode is for more accurate encoder position. I'm not using that. Okay, mux 4. This is your increments. So I set mux 4 input 0, input 1, input 2 with my graduations that I wanted. The inputs for that come from parallel port pin 8 and parallel port pin 9. In theory, with the mux 4, you could get 4 variables out because you've got 2 inputs, so you've got both on, one on, other one on, or both off. Then we link the pendant scale to the mux output. So you've got to do this for all your axes, so axes 1 through 4, and then I did hell you are feed override scale. So here I went through the hell you are documentation, and I found I wanted to override my feed override at my 5th position of my rotary axis switch. So I linked the scale here. We'll get to the selection in a little while. Then I linked my encoder pins. You'll see here that it's on my one it's parallel port pin 3 and parallel port pin 2 in the wrong order. I did that because I didn't feel like rewiring my encoder once I'd installed it. It was moving the wrong way, so I just literally switched these instead of rewiring. Okay, now what we do is we set the enable pins for the axis. So enable pin axis 0, which is my x-axis, is attached to pin 4 of my parallel port. Enable axis 1 is to pin 5, 6, and 7, and so on. And then my feed override count enable was added later. So here I was saying hell you are feed override count. So that's how many encoder pulses. And then we enable it. That's attached to parallel port pin 15. Then we're attaching the pendant encoder counts to each axis. And that is done with the encoder counts. So that basically looks at what the encoder number was and what it is and the difference. And then again, you've got to add it to your hell you are .feed override counts. Then lastly, I added a power button. So when I release my e-stop, I can then push the power up button and that powers up the machine. That way, I don't have to click on the screen to power up my machine. Basically, I went again into hell you are, attached power signal to hell you are machine on. That is a input in the hell you are that when it goes high, it will turn the machine power on. There's one for machine power off as well, but yeah, I just use power on because my e-stop kills the machine. And that is attached to pin 13 as an input on my parallel port. And when I push that, if the machine can power on, it will power on. And that is basically all my code. If you want to grab a copy, just send me a message or leave me a comment and I'll happily share it with you. Thank you for watching, and hope this helped you guys out.